Hello, it's Keith here, and this is the 7th in the platform-specific series of my 68000 programming tutorials. Now, we've been looking at bitmap graphics on various systems over the last few weeks. This week we're going to move on and we're going to look at how to read in from the joystick or the joypad, because of course there's no point just getting graphics on the screen. We need to process some kind of input. So we're going to be looking at the joystick routines that we used in Grime 68000 to read in the player's movements, and they of course were used to play the game. This week we'll be looking at the X68000 by Sharp, and we'll be looking at how to process the joypad on those systems. Now, quite curiously, the 68000 doesn't have its own joypad. It does, however, allow the use of two other joypads that already exist. It can use an MSX2 joypad, or it can even use a Sega Genesis joypad. So we have a choice of a 2 fire button joystick or a 6 fire button joystick with 2 extra select mode buttons. Now, in these tutorials, we're going to be outputting our data into a standard format for our game to use. Now, this comes from the original Z80 series, where we were using a single byte for all of the buttons of the joystick, and in that case, we were using bit 0 as up, bit 1 as down, bit 2 as left, bit 3 as right, bit 4 as fire 1. If there was a fire 2 and 3, they would be 5 and 6, and bit 7 would be any kind of start button that joypad had, if there was one. Now we're going to extend that and add an extra few bits now, and all of the extra buttons will be added to a second byte within the word that we're returning from our function, so that if our game is more advanced we can use those. But if we are converting a game from a Z80 using the code in my Z80 tutorials, we'll have the basic same structure for our joypad buttons. In all of these cases, a button being pressed will return a 0 in that bit, and a 1 will mean the button is not pressed. Let's have a look at the actual code and see it running. So here's the code as we will see it today. Now you can see here we've got some hexadecimal values up here from the monitor, and the top one is the first joystick and the second one is the second joystick. And the code we've got here just has a command called allow joysticks. This turns on any initialization. In the case of the 68000 we don't need to do any, but in the case of systems like the Atari we do. But that's just a starting routine. And then we've got a command called read controls dual, which sets D0 to the keys of the first joystick and D1 to the keys of the second joystick. And we're just looping around here, repeatedly showing that. And I do have here 2 joypads that are plugged into this system. I've got a pair of Super Nintendo joypads here, so we'll just press some buttons on them. And I will press button up, and you can see here we've now set bit 0 to 0 because I'm pressing the up, and there's the down, left, right, and we've got all kind of fire buttons here. And then I say have a second joypad here, and you can see up, down, left, right, fire, 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 and more fires. So we've got lots of fire buttons here, and you can see that we can read them all in from this bit mask. So let's have a look at the actual code that is reading these joystick buttons in. Now here's the code that actually reads in the joystick on the X68000. We've got some initialization here and some code to shift the joystick buttons from the default values that they come out of the X68000 into the format that we're using standardly on all of our X68000 machines. Now, when it comes to the X68000, there are 3 ports we need to know about to be able to read in all of the buttons, especially if we're using one of those Sega Genesis pads. Now there is a single port for joystick 1 reading in the buttons from that, and there is a second port for joystick 2. However, whenever we read in, we don't read in all of the buttons if we want to read in those extra buttons. So what we need to do is use a third port, and that is E9A005 here. And that will select whether we're reading in the basic buttons or the extra buttons. And the way we define that is by setting these 2 bits here to either 0 to read in the basic buttons or 11 to read in the extra buttons. And you'll see that represented in our code. Now in this example we've got a function called joystick process 1. This is used twice, and what it does is it converts the joystick input from one of the joysticks, either joystick 1 or joystick 2, into the order that we want to standardize on. And what it's doing is it's using A0 as a port, which is either going to point to joystick 1 or joystick 2 here. So what we're doing is we are selecting joystick 2's data port into A0, running the routine, backing up the results into the stack, running it again for joystick 1, and then we're pulling the original value for joystick 2 out of the stack and moving that into D1. And the reason we're doing that is because D1 is actually used here. Now alternatively we could have replaced all these D1s with a D2 or something to mean that we didn't need to use the stack, but that's the way I decided to do it in this case. So the first stage is selecting the port that we're going to read our data from. How do we actually process the joystick? Well, first of all we're going to use D0 for the result here, so we need to clear that and make sure there's no junk data in it, and then we need to select the default buttons. because first we need to select this port here to all zeros so we can get up, down, left, right and the first 2 fire buttons. Now that we've selected that port, we then read in from A0, which will be pointing to one of the joystick's data port, and we read in and we will get something looking like this: up, down, left, right, an unused bit, fire 1 and fire 2. Now we need to get rid of this unused bit here, and so what we're doing here is we're shifting all the bits we want and we're moving them through the extend bit. So we're shifting them out into the extend bit and then shifting them in to our resulting data here. Now once we get to this point, we now need to skip over this unused bit here. So we're doing 2 shifts and then we're moving the first fire and the second fire because that's the format that we want to have here. But now we need that third fire. Now the third fire, if you remember, is actually in the extra buttons, and so we need to reconfigure this port to this bit mask here. And so that's exactly what we do. You can see we're outputting that bit mask to this port here, and that now selects in the extra buttons. Now what we're doing at this point is we're backing up the result of reading in that port again into D3, and we're going to use that later because we need to get that third fire button and the start, and we need to put them just here, but then we want to put any extra buttons at the end here. So we're backing it up for those extra buttons later on, and then first we're going to get the fire 3 and the start button. And so what we're doing here is we're shifting along the bits to get past all of these and to get that third fire button, and we're shifting that into our resulting D0 here, and then we're shifting one more bit again through the extend and we're shifting that in as well. So now we've got fire 3 and start. At this point we're now masking D3 so that we're only keeping this bottom nibble here, and we're then shifting those to the left to move them into the correct position to add them to the end of our word here. So we'll be copying these into this position here. And that's what we're doing with this OR command here. Finally, we set any unused bits within our resulting register here just for consistency, and then we return. And you can see we've got the allow joysticks command here. That's a dummy command so that we've got compatibility with other systems that do need some kind of initialization to turn on joystick reading. So that's really all there is to it. So we select our port, we process the joystick. The processing of the joystick selects the default joypad buttons, reads in the bits in the right order, selects the second set, reads them in the right order, and then returns, setting any unused bits here. That's really all there is to it. It's quite straightforward and it works quite nicely. And here's Grimes 68000 using that joystick control, as you can see here. So it definitely works just fine, and I play quite badly with it. So there we go. The X68000 gives us a relatively convenient way of reading in the joysticks. The only slight quirk is we do have to use that extra port to select between the two, but really quite easy. Anyway, that's all we're going to do for today. That's joystick reading on the X68000 covered. Next time we're going to be doing the Atari ST, and we're going to be looking at how to read the joysticks on that system. Thanks for watching today, and goodbye.